Hello everyone, my name is Pompey and I am from Sri Venkateswara College of Engineering. So today we are going to discuss about a support vector machine model. So it's also called as SVM. So support vector machine or SVM is one of the most popular supervised learning algorithm. So which is used for classification as well as regression problems. So as you must understood that it's an algorithm and that is used for classification and as well as regression problems. So we'll be discussing about regression problems later. So however, it is used for classification problems in machine learning. Then the goal of the SVM algorithm is to create the best line or decision boundaries that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. So the best decision boundary is called a hyperplane. Suppose there are two different datas, so take it as stars and squares. So you want to differentiate or put a boundary in between them, so you should take the maximum difference. I mean, there should be a minimum distance from each and it should be further from both of the data, so that differentiation will be done by hyperplane. So this is hyperplane and SVM chooses the extreme point vector that help in creating hyperplane. So this is where SVM comes. So support vector machine chooses the extreme points and that helps creating the hyperplane, and these extreme cases are called support vectors, and hence algorithm is termed as support vector machines. So then we have one of the key advantages of SVM is its ability to handle high dimensional data with relatively small sample sizes. So this makes it particularly useful in applications where there are many features but few examples, such as image classification or text analysis. So when it comes to high dimensional, it might be a 3D, 4D and such kind of dimensions. So it's not only limited to 2 dimensional. So and it can handle large amount of data, different types of data types. So this is the introduction and coming to working. So firstly we have first scenario, identifying the right hyperplane. Here we have three hyperplanes, so A, B and C, and now identify the right hyperplane to classify stars and classes. So among these three hyperplanes, so will be this there are three hyperplanes, right? A, B and C. So we need to classify or we need to classify or between these two different data types. So it can be A. So because of the star data type is too close to A and it's little far from it's cutting through the data of circles, so it can be A. And coming to C, it's also same. It's very close to A and it's cutting through the red circles, so it can be a hyperplane. We're coming to B, so it's actually there's a equal distance among both of the data and it's cutting through the different data, so it is classifying that this data type is a star and this data type is a circle, and there should be this line should be always further from both of the data sets. So because suppose if a new data set is added and if suppose it's added furthermore here, so then also it should classify that it's a star, and when it's added furthermore further data is added in here, so then it should classify it as a circle. So that's why B is considered as hyperplane. So that's why SVM so see, select the hyperplane which segregates the two classes better. So in this scenario, hyperplane B has excellently performed this job. So as we know, B is the hyperplane. So identifying the right hyperplane. Here we have three hyperplanes A, B, and C, and all segregates the classes. So yeah, as I said previously, if there are three hyperplanes, none of them are cutting through any data. So it's obviously it's segregating. I mean classifying both of the data. But as you can see, B is very close to star data, but and very far to circles, and A is also very close to circles, and it's very far from stars. So if suppose a new data is added here, it will be classified as star when we take a hyperplane as A. So if we suppose a new star is added here, and then it will be taking star as a circle. So this is where we should take C. It's an equal distance, so C will be the hyperplane in this case. And here you can see the margin for hyperplane C is high compared to both A and B, so we name the C as a hyperplane. As I said, we'll be taking the C as a hyperplane. So if we select a hyperplane having low margin, then there is a high chance of misclassification. When the A has obviously low margin, so when we select A as a hyperplane, it will obviously lead to misclassification, and due to when new data sets or new data is added, or it is integrated, so at that time it leads to misclassification. A circle can be classified as a star, and these kind of things will be happen when we take low margin hyperplane. Okay, so coming to the binary classification, we are importing skitlearn from so we are importing SVM from skitlearn, and model selection, and from model selection we are importing train testplate. So this train testplate is used to split the given data set into training data and testing data. So that is why it is used. And coming to this x set, and see, prepare your data. X as a future matrix and y is the largest variable. So these are data, these are variables, and we are splitting these two into training data and testing data. And as you can see here, we are splitting it. So we are creating a classifier. So classifier can be created, then classifier will fit x the training data. So we will be fitting x training data into classifiers. So then make predictions on the testing data. So ypred is a like prediction. So suppose you give a new data and it will predict or where it doesn't belong. So after everything, we'll be calculating the accuracy of the model. So then we'll be predicting the accuracy. So advantages and disadvantages. So it can be also called pros and cons of SVM. So one of the main advantage of SVM is its ability to handle high dimensional data. That means it goes beyond 2D. So it's not only limited to 2D, and data with relatively small sample sizes, as mentioned earlier. So additionally, SVM can be used for both classification and regression tasks. So it also has a solid theoretical foundation and can provide good generalization performance. So obviously the performance is good. So coming to cons, so SVM can be computationally expensive, especially for large data sets. Suppose there is a big huge data set, and implementing SVM will be really difficult, as it requires much bigger computational components. So it is also sensitive to choice of kernel. So it depends on the kernel, so kernel function and parameters, so which can affect the performance of a model. So it depends on what kernel you are using. So finally, SVM can be difficult to interpret due to complexity of the optimal hyperplane. You must have you seen that a hyperplane is chosen based on their margin, low margin and high margin. So if both have same margins, so on that basis the hyperplane is selected. So there's a complexity in that selecting. So SVM can handle both linear separable and non-linear separable data using different kernel functions. So the kernel trick allows SVMs to implicitly map the data into a higher dimensional space where it becomes linearly separable. So this flexibility enables SVM to capture complex relationship between features. So non-linear and linear separable data like the SVM different kernels. So it use it makes the it plays with actually dimensions. So with a higher dimensional where it becomes linearly separable, so that makes it more easier to classify the data. So SVM create a complex decision boundaries, so particularly with nonlinear kernels. So this can make it challenging to interpret and understand the model inner working. So unlike more transparent models such as decision tree logistic regression, so it's not that much of transparent. So this is it for the support vector machines. So thank you.